All right, we'll record this, so you don't need to take notes or anything. Your goal is to be as present as possible. As questions come up, you can post them in the chat, and then we'll just get this started to respect time on Saturday. Welcome everyone. I'm Michael, founder of Worldwide Studios with Dylan. Our main goal is to help people learn and build with the latest tools in AI, because the tools are changing so quickly, and the capabilities of those tools are shifting so quickly. And for context, in the software world, vibe coding is really like trending, from like Karpathy, who was previous lead at OpenAI and Tesla, saying, hey, I just made a whole iOS application and I'm not an iOS engineer. Y Combinator says up to 90% of current startup code bases are vibe coded. YC is just a global accelerator. And when we saw that, it's like, hey, there's a lot of awesome tools like Flux where you don't just have to vibe code your full stack software application, you can also vibe code PCBs. And so this is an experimental hack. This is the first time we're doing this. The Flux team has been doing awesome design competitions, and their team is going to be here to support you throughout the day to be able to help you build whatever ideas that you have coming in. And so we've got a full day where we're going to go from idea, working on Flux, and then demo. And just to kind of set some expectations before I hand it over to Nicholas for the introduction. One, our main recommendation is be as ambitious as possible. So this is a hackathon, and while it's collaborative, it's a little competitive. We've got prizes at the end of this, and worst case scenario today, you just do the safest path. You're like, okay, I'm going to make like an LED blink because I found that on the template, and that's the safest thing I can do today. Do that. Don't do that. Be as ambitious as possible. You're going to have more fun working in your team being more ambitious. And we're really trying to push Flux and Flux's Copilot as far as it can go. It's okay if you hit certain blockers or failure. We've got the team on Slack to support you. So my main recommendation, be as ambitious as possible. Ethan was talking about an AI wearable. Could you do real-time video with that wearable? Gemini 2.5 Pro can do video in context. Could you build out a camera module on that wearable where you're actually streaming video? So be as ambitious as possible today. Two, these tools are not perfect. So I was using Copilot today, and it's crazy. It can make schematic updates. It can teach you about components. It can help you search the library. And just with any kind of AI workflow, it's not perfect. There are going to be some things that break. There are going to be some things that surprise you. And so keep track of that. We're going to have the Flux Slack open where you can comment things as you get stuck or need some more support. But we're not quite at a place of vibe coding where we're like Rick Rubin style, where you just have a thought and it just appears. There is still humans in the loop, and that's going to make it fun for today. And then lastly, just like do what makes sense for you today. And so it's a Saturday. Some people might have like a coffee chat with a friend at noon or whatever it is. Take some time. That's fine. We just have one goal today, which is demo by 4 p.m. And I'll pull up the guide. We have a source of truth here. The main goal today is just demo by 4 p.m. And so in terms of doing what makes sense for you, one, some of you might be already working on a project and you want to keep working solo. Totally cool. You can run this whole hack solo. That's a way. That's a vibe. That's a way to go through it. Two, if you're like, hey, I didn't come to this virtual hack to work alone. My background's here. I want to meet other people here. We've got some teams preformed, and we'll make teams at the end of this. So you can also work in teams for today. But everything else is kind of a choose your own adventure after this kickoff. And the goal is just get ready for a demo as far as you can push it. And the last thing I'll say too is, while our main goal for today is design new PCBs and be able to demo them in Flux, you can also do other things that complement that. So for the AI wearable example, if you wanted to do something with like 11 Labs voice module to show what could happen when you start tuning that system or having different feedback loops, the number one thing you've got to demo first is the PCB. But after you demo in Flux, show us the 20, 30 seconds of the voice demo in 11 Labs. For people who want to do enclosure design, open up your favorite CAD software, make a quick mock-up for that enclosure. If you don't want to do that and you want to stay vibes, ChatGPT image is so good. I was just mocking up a walkie-talkie teaching render. Boom, I now have a render in like 2 minutes. So the number one thing about the demos, we're going to be focused on Flux. So you don't get to do extra until you do that. But for today, again, do what makes sense for you in terms of your team, your timeline, and then also whatever it is you want to build to just make it the best demo at the end of the day. So that's the intro. Nicholas, anything you want to add just from like context or intro-wise before you jump into the introduction for Flux?
So, hey guys. No, not really. It's a good point about like trying to add complementary things outside of what you can do in Flux. There's like firmware, like specific firmware stuff that you can do for the device, like add things on the 3D, or use whatever favorite CAD you like to use, and add enclosures. You can even add them to your Flux project as well, like add the enclosure to the Flux project so that like you can view the whole thing in 3D. Like all those things add up. It also make it way more fun when you start seeing something that has the shape that that you want to build. If you haven't had the time to build the whole PCB with all the components and route the whole thing, we have an auto router that uses AI, but maybe it wasn't fast enough, or you got the last minute. But you can add things on top of it, and when you see something that looks like what you wanted it to look like, uh, it's all a lot more fun.
Awesome. Appreciate that context. And so use the chat as questions come up. Our main goal for today, we're going to go over Flux. After we get the introduction of Flux, then we'll have time for breakout rooms where we can meet different people on the call to finalize teams. We also might have some people joining throughout the day. So if you get added with an extra person, go for it. And so we'll do the intro to Flux. You get to meet different people, and then you'll be off on your way building. We have two forms of support. We'll have the Slack channel and also the Zoom call open, kind of like a main room and a hack where if you have questions, you can always come back. That is more than enough for me. Nicholas, welcome. We've got Nicholas from the Flux AI team. Again, he's run global design competitions. He's put together a lot of the guides himself on Flux, and he's going to be one of our leaders, just being able to help get introduced to Flux and help us all get started. So Nicholas, take it away. And so glad you're here.
All right. Yes, thanks, Michael, for the intro. Yeah, just two things about me. I'm Nico, product expert here at Flux. I'll be online for the first like 4-ish hours of the competition. I'm gonna send you all the links and everything you need to know if you need support from Flux and the Flux team. I'll be joined by some other team members these first 4 hours, and then some other folks from the team are going to take over for the last 3-4 hours of the event, so that you always have at least somebody from the Flux team that you can ask questions if you get blocked. Pretty much everybody on the team, at least from Flux today, knows about electronics design as well. So if you happen to have the questions or things along those lines, I'm going to teach you how to ask Copilot, which is a great coach on everything electronics wise. But if you need more an idea of how to ask something, or more like a pointer because you're unsure, we also know about electronics and PCB design. So we'll be able to help out a little bit on that end too. So first thing first, I just sent a message here in the chat to a project in my personal Flux account, where you're going to find, I'm going to share my screen and show you, but you're going to find there all the links that you might need in this competition, sort of Flux-wise. So this is what you should be seeing when you open the project that I just shared. So I see that there's folks already coming in. So this is what you'll see when you create your Flux account and you start a project. You're going to have this interface. This interface, of course, is already pre-populated with some comments and things that will be useful for you during the competition. We have two halves here. The first half on the left, you're going to see all the links that you might need. These projects are going to be live from now on, basically forever. So at any point in time, you can go back to this. If you missed a link or something, you're going to find all of them here. You have our Slack community, and then the specific channel that we were using that's called Vibe Coding Hardware. So if you open that specific channel, you're going to see this this channel. It has some ideas or some tips on how to ask for support from us. So if you need some help figuring out how to do something in Flux, or how something in Flux works, or you find something that you don't understand why it's not working, please make sure that you follow these few steps, which is sharing the project with our Flux account, starting a new thread, and also you can use Loom to create a quick video explain the issue. It's sometimes much easier to do like 15 seconds of a Loom video explaining and showing what you want to show than trying to type something and then create screenshots of the thing. It's going to be a time saver both for you guys and for us as well. Then you're going to find a few links on our documentation page, YouTube channel, and a few blogs that we've created that might be useful for you guys. So 9 tips, sort of troubleshooting, like the sort of an FAQ of Flux, and then 20 Copilot example prompts that will be useful when you start using Copilot for your specific project. Okay, so I'm gonna take roughly like 15 minutes or 10 to 15 minutes to explain a little bit about the user interface and how to do the basic things in Flux. Some of you might be already familiar, some of you won't, and then I'm gonna take some 5 minutes at the end to answer any questions that you might have. So Michael, if you see something in the chat that it's absolutely critical that I need to answer, feel free to interrupt me, and I'll respond right away. Otherwise, I will just do everything at the end. Okay, so Flux interface. This is what you'll see when you create your account for the first time in Flux. It's kind of like your profile page. You're gonna have a few learning projects here. So if you click on any of this, you're gonna see sort of like a quick tutorial on how to get around. I'm gonna cover that now, but you also have it here in case you want in the future. And then you're also gonna see a list of all the projects that you start creating or collaborating with. Like if you start collaborating on other people's projects, you'll also start seeing them over here. To create a new project in Flux, you can either click on the new project here, or you can start from a template. Templates have things like if you're planning to use a specific manufacturer, you have all the rules for that specific manufacturer, things along those lines. Probably not the something critical for this specific competition. You can definitely start from an empty project, but in the future, if you want to use a specific manufacturer, you might want to do that. So if you start a new project, you're going to see this interface. Of course, you're not going to have all these pre-populated comments, but it's going to be the same interface. And it has essentially two main toolbars. The one on the left, where you're going to see the part library and then the list of objects. The part library is essentially a public library of electronic components that's ready to be used by anybody. So for example, if you're planning to use a microcontroller or an audio device or a DAC or some Arduinos or whatever it is that you might use, that you might need, it's very likely that you're going to find it here in the library. So for example, I'm going to find an STM32. It's a very popular microcontroller for IoT type of devices. If you find a part that you want, all these menus also expand if you want to see more information. You just drag and drop that into your project. At that point, the component is going to have a reference. You want in this case, it's going to have all the pins that you'll need. You can also create parts on your own. And we're going to be on Slack there as well. So if you have any trouble creating parts or you need a specific part, we might be able to help add you some of these parts to the library so you can use them in your own designs. So that's the very first thing. Second thing is the object tree. The object tree basically gives you a list of all the objects that you're going to have already in your project. So this is sort of the list of potential parts that you can add to your design, let's say the library, and the object tree is all the components that you have already added to your design. So in this case, I have 2 nodes, and then this component that I just added here. A few important things about Flux and the way it collaborates. To share, and this is going to be important if you work in groups, you can share your project to other members of your team. You just need either their Flux username or the email address. So you just type them, for example, I saw Basil, a teammate of ours, just type the name, the username, or the email address, and then you click on the add button, and you just add that person. Example, so yeah, Vasi here. I add him. For example, I can give him edit access, add, and then he's added to the list. Same thing if you need support from Flux. You just type the support, like support, and then the support account here, Flux support account, and then you can add them. So this is going to be important if you need to work with other members in the same project, that you share the project with them. Then they just need the link, the URL of the project, and with that, they're going to be good to go. The other important thing is version history and cloning. Version history is essentially like every single change that you made into the project is going to be listed here. So if you mess up, you can always go back in time, make sure like figure out who made the change, and then revert back to the previous version if needed. And the other one is forking or cloning. Sort of cloning and forking essentially do kind of like the same thing. They create a copy of the project in your own account. Cloning basically creates a copy of this specific snapshot of this specific version and this version alone. Forking creates a copy with all the history that came with it. So if you see this change history, you're going to have all that if you fork, but you're not going to have any of that if you clone. Comments, both with Copilot and this type of pinned comments that you have here, all those are going to be lost when you do the cloning or forking. And this is going to be important because of a few things. Whenever you create an account in Flux, you're going to have 2 weeks for free. And I think it's like 500 Copilot credits included. So every time you interact with AI, either by using the Copilot chat here on the right or using the auto layout here, this feature, both those features consume Copilot credits. So you're going to start consuming them until you get to 500. If you go over 500 credits, you are going to see, you're going to start to pay for those credits. So if you're going to be working in teams, what you can do is you consume the first 500 for the first team member, then another team member comes in, forks the project, and then you continue using the credits of the second team member, and then the third, potentially, if you're three on the team. So basically, you maximize the number of credits that you can use in the competition. If you run out and at last minute you're scrambling because you need to do something, just reach out to the Flux team in Slack, and we can add a bunch more credits to your account. But it's also a good opportunity so that different members can drive and share the screen and do some work. So because the first 500 credits is going to be in one team member's account, and the second is going to be another team member. So that gives everybody the opportunity to be the owner of the project and sort of drive and add the components and do the design and those sorts of things. So Copilot. Let me move the video things out of the way here. Okay. So on the menu on the right, you see 3 tabs. The inspect is kind of like a properties menu. So every time you select a component or anything, you're going to see all the different properties of that specific component. In this case, I see all the properties, the component name, description of what this part is, a link to the datasheet. So if I click here, I'm going to go straight to the components datasheet, kind of like a properties menu of that. And then at the very bottom, you're going to see if this component is available on different suppliers, what the price is, what the quantity is, and the different price breakpoints. The third one is a review tab where you're going to find a few things that will help you make sure that your project is doing well. Design rule checks are basically checks on your schematic, on your PCB layout to make sure that your layout is is correct. Things like that you don't have traces that that are over each other, that overlap, or that footprints that are missing, and things along those lines. Um, and then manufacturing passive components, these two are AI based and they work on the schematics. So for example, in this case, if I hit on um, the play button here, I'm going to be asking our AI engine to check all the resistors in my design and make sure that they have the right power rating. There's a few checks like this that you might want to run. These are usually kind of like at the end of the design. And then, yeah, definitely bonus points if a design is sort of error-free. So the less errors a design has, that of course means that the design is more complete than one that has a whole bunch um, of errors here. And then the third one is the way that you chat with Copilot. Now, I'm going to show you a few things about Copilot here, but first, a few things that is interesting to see or to know about what Copilot is good at and what Copilot is not good at. You have the list here, so you can refer to it at any point, but it's definitely Copilot is good at coaching you through a design, have him explain what type of components you need, what is the minimum set of components you need to accomplish a specific task, help you brainstorm ideas of projects, make sure that a project might be the right level of complexity, depending on your skill set. So for example, if you're a beginner designing PCBs, you can ask Copilot to help you figure out what is a good level of project or something is too complex or not. It's very good at teaching you electronic concepts and sort of all the fundamentals. So if you're not sure about how a GPIO works or how a microcontroller works or what a specific interface is, or even like very fundamentals of electronics, like current, voltages, resistors, capacitors, all that Copilot is great at. Is great at figuring out what parts you have, looking at the data sheets and answer questions. For example, what is this VDD pin or what is this PB7 pin? What does it do? We go in, check the data sheet of the device, and then reply. Is very good at. Is very good at finding parts and part alternatives. I'm going to do a few examples here now. Is very good at that. And the things that it's not great at is answering sort of very broad and vague questions, and specifically if you want a specific output. So if you're looking for a specific output and your question is too broad or too vague, that's when things are not going to be so good. So it takes some time. It takes some getting used to and learning how to use an AI engine, and Copilot is no different. So try to be as specific as possible. And if you're not sure, try to start refining the prompt. So you ask something a little broad, and then you go more selective and more selective until you reach like a very specific request. And then the other thing is, it's not great at generating entire schematics or adding 20, 30, 40 parts at once. It can add parts to your design, but it's not great at doing, hey, Copilot, add all the parts that I need for an AI pendant. That is at the very least 50 to 100 parts. You're not going to have good result adding all those 50 to 100 parts at once. It's much easier and much more accurate if you do them in blocks. So for example, you can ask Copilot, hey, Copilot, what do I need, or what blocks do I need to design an AI pendant? So this is how you start broad, and then you start refining. So you're going to see what all the blocks are that you might need. Then you can zoom in one block and say, oh, okay, power. I need power. Okay, what type of power? How do I power this? And then you figure out exactly what type of power circuit you need. And then eventually you say, oh, okay, now I know that I need this exact thing for power. Can you add these components to the schematic? And then Copilot will basically add all the components to the schematic. That's the way that you're gonna get a lot better results. And similarly with wiring components to each other, right? If you ask Copilot to wire everything, so I place 20, 40 parts and I ask Copilot, hey, wire everything. It's not going to do a great job. Now, if you start honing in and say, okay, Copilot, I have this IC, and I need to wire, for example, a microcontroller. I have this microcontroller. I need to wire this microcontroller to this sensor. How do I wire these two things together? Then it's going to do a much better job at. So make sure that you go as specific as possible, especially with these adding components or wiring components. So for example, what I was sharing before is like, hey, I have a battery, and then I have it, charging management for USB, and then you can follow up with for the charging management block, what options or architectures can I use? And then you start going in, you figure out exactly what you need, and then you ask Copilot to place the parts in your design, and then you move on. You can also split different threads. So this whole thread, Copilot will have in its context. If I spin up a new thread, then it's kind of like starting a new blank conversation. If you have used OpenAI, basically the same, or ChatGPT is basically the same way. These are essentially different conversations, and the whole context is preserved, and you can go back and use it. Another thing that Copilot is great at is creating these block diagrams, so where you figure out what are all the parts or moving pieces that you might need for a specific design. So that is a little bit about Copilot and Flux in general. We shared a guide with some other sort of more advanced ways of interacting with Copilot. So for example, you can use these specific tools. So when you use the library tool, Copilot will search components in the library or components that are available publicly in the library instead of every single component out there in the world. So it's going to only consider the library for that specific question. You can also type at U1, for example, when you want to talk about specific components, you can reference them like this. And that makes sure basically what this is telling Copilot is, okay, I want you to grab everything you know about this component. So Copilot is going to grab the description, the name, the data sheet, everything that it knows that it has about that component, and it's going to put that into the context before answering the question. So you get much more accurate results when you do things like this. You have a few different models that you can use, depending on if you want sort of faster for maybe like if you're asking very basic electronics questions, you might use the fast model because it also consumes less credits. You have kind of like something in the middle, which is the general, and then sort of more advanced reasoning if you want something a little bit more advanced. You can attach files, things like PDFs, graphs, charts, things along those lines. Copilot is good at figuring out PDF tables, graphs, things like a temperature graph or things along those lines. It's not great at parsing, for example, schematics. So if you upload a schematic of another circuit, if it is very simple, it might do a good job. But if you cannot basically upload a schematic with 40 different parts and then say, hey, I want this exact same thing, that is just not, it's just not going to work, unfortunately, at least not for now. And then you can search the web. So there's no need to go and use other AI engines. Calculator, if you're doing math things or math problems, you might want to use this specific tool. And then one at the bottom that is, I have the Zoom menu covering it. But I think there's something at the bottom that's the the helper, I think. Yeah. So the helper or the help tool essentially looks in the document in Flux documentation to answer the question. So if you want to learn how to do something in Flux, and you don't want to read the documentation, you can use the helper or the help tool and have Copilot help you how to do things in Flux. Of course, we're gonna be on Slack as well, so um, that's another option as well. So let's see. Okay, finally, before I stop here, the feature projects page is a good collection of very basically end like finished designs that you can use sort of as a inspiration. So if you're not sure what you want to build or things along those lines, um, there's a whole bunch of projects here that you can also use for the search. It's good for inspiration. It's also good for understanding how you might want to do something. So, for example, let's say that I want my component or my design to have some sort of battery or things along those lines, right? So you can find this power bank or find an example that has a battery. So you can, for example, open it and then figure out how that was made, right? Um, so you come in and say, oh, okay, how does this person figure out how to do the charging system, or what charging um, component did they use? How did they wire this specific component, right? Like all those things you can go and find in other projects. How did they do that? And then adapt that to your design. And a pretty cool trick is what you can also do is you can clone this project so that you have a copy and then ask Copilot things on this project. So for example, it's like, hey, why does this person use this capacitor on this IC? I don't know. Or why did they use this IC and not another IC? Or why do they have two USBs or whatever that is? You can clone the project, ask Copilot to explain why that was made that way, and then use that information to sort of speed up the way that you design and kind of like do not reinvent the wheel. So if you find, oh, this USB is exactly what I want, you can even Control C and then go back to your project and Control V it. So you have the part of the circuit. That also helps speed up designs. So if you see something that, oh, this is exactly what I want, don't do it again. Copy, paste, move on. So that's a little bit about Flux and some tips on how to do more work in less time. Um, I'm gonna take a look at the chat and see if there's
Yeah,
something.
we got a few questions coming in. Thanks for that overview. The Control C, Control V is such a hack, being able to bring in things from different templates. Also really good to know you can tag specific components. This morning I was trying to break Copilot, like do everything, and I definitely saw that limit there. So thanks for sharing those tips. One question coming in from the chat is, can you explain a little bit more about how Copilot is set up for Flux specific workflows? Because the question coming in is like, should I be using Gemini or should I be using ChatGPT in their chat window? Like when do you think kind of switching between them? And just explain a little bit more for like the context that Copilot has on Canvas, some of the agentic abilities to change the schematic. Help us understand like when we should be using Copilot or when there might be an opportunity to try something else.
Yeah, that's a good question. So Copilot essentially has context of every part that you have in your design. So it knows that I have a USB connected to a transistor, connected to potentially this microcontroller. It has the data sheets of each component, and the data sheet contains all the information that you need for a specific component. So it's going to be much better at, for example, when you need to find part alternatives or when you need to add specific parts into your design. Say, hey, I want to find an alternative to this part and I want to add it to my design. You can say something like, what is a good alternative to one that has more RAM memory or more RAM? Um, if you need to explain all that in another AI tool, it's going to take you a while because you need to find the information about that, copy and paste the whole data sheet so that OpenAI or Gemini knows what you're talking about, and then find you an example, come back here, make sure that it's in the library, and then find it and then drag it, it's going to take forever. Uh, you can do these things here. If, for example, you want to understand how a specific circuit works. So, for example, you found this, it's like, I think this is what I want. You can ask Copilot, hey, I found this. You create a new project, you paste this, say, hey, I found this charger for a battery charger. Is this going to work in this if I want to use this design, if I want to design this type of thing? Copilot can very quickly know what circuit you have, what parts, how those parts are connected, and then reply. How do you explain? It's very good. It's going to be very, very difficult if you need to explain this thing to another interface. Now, if you want ideas or like electronic concepts, basic electronic concepts, things like that, you can also use other tools. But yeah, things like basically everything that will benefit or that you'll need to explain the current circuit to the AI engine is going to be much faster in Flux because Copilot already knows all this. It knows all the parts, it knows how those parts are connected. It can interact with the design. So, for example, say, yeah, it says, okay, this is slightly larger package, has more RAM. Okay, I'll go with the higher part. And then Copilot is going to find that part in the library and then add it to my design. So that's much faster to do in Flux than using other tools.
Great, thanks for clarifying that for Copilot and Flux. Another question came up in terms of the review tab. Are those standard reviews for all projects, and can someone add their own review? Maybe just walk through, how the review tab works.
Yeah, so these come with Flux. You cannot really add. Yeah, here's the part that Copilot just added for me. I have a whole bunch of comments here, but yeah, the part is right there in the background. So these come with Flux. These are for for the PCB layout. And what happened here? So the other ones, the ones that are for the schematic, so the capacitor, the passive reviews, so passive components, so check power ratings, check pull-out presence, check capacitor voltage ratings, things like that. These are AI based, and what that means is that you can also do whatever you want. So, for example, you can ask Copilot, "Hey, Copilot, is Q1 the right it has the right power rating for powering powering a USB charger?" And you will go check the power rating of Q1 and then answer the question. So essentially, you're constructing your own review. You can ask Copilot to review that all your USB devices are USB-A or USB-C, or check that specific components are hand solderable instead of machine solderable. You can add any review that you think of. It's just that they're not gonna be present here. You need to ask them in the Copilot tab. These are ones that we know that work pretty well and that users have been using over and over and over. So we just basically create a shortcut. But what this is doing is asking Copilot to check all the resistors and make sure that they have the right power rating. That's essentially what this thing is doing. So you can create your own by asking Copilot.
Great, thanks for sharing that. And then someone also just had a follow-up question on unit tests. Does Flux have built-in unit tests to ensure the designs will function as intended, or is that something Copilot can help with? And if you already covered that, we can move on past that question.
That's a great question. So we do not have unit tests, mainly because we're still trying to figure out prompts that work on every scenario, right? And that's the hard part of this. So you can create your own unit tests and ask Copilot, hey, I have this charger and this, will this charger work for this microcontroller that I have. Make sure that you check power, voltage, current, everything. And Copilot can do that. So you can build your own unit tests for the project and then craft the prompt and have Copilot do it. We haven't created sort of this type of shortcut yet because it has been very hard for us, at least up to this point, to create a single prompt that will work on any instance and for the multiple different um, units or blocks that you're going to have in your design. So yeah, you can definitely do it. You can definitely ask Copilot to help you out with that. It's not built into Flux yet.
Sounds good. Thanks for going through that. And then we had another question for the demos. Could you maybe show the 3D view? So as people have 3 minutes to kind of demo their final project, maybe any other tabs you want to show too alongside the 3D view for PCB. If there's anything people should know, from tab wise that we haven't gone through yet.
Yeah, so this code is basically to build some automations and more importantly to interact with Flux's simulator. So you probably won't be using this for this competition. Of course, feel free to dig and investigate and learn, but it takes a while, and I'm not sure that's going to be the right approach. And then the PCB layout, you have the 2D view, and then if you click here on the 3D view, you have also a 3D view of the layout. You can, the same way that we added models for the parts, you can add models for the enclosure. If anybody wants to do that at some point, there's information in the documentation page, or just reach out to us and we'll let you know how to do it. You can add enclosures to the 3D model. And this is the way I would demo what I have. Basically, try to go through the schematic, teach or show what I created, and then show the 3D view. And if you have enough time to do the schematic and to do the component placement, you can use the AI auto layout here. This is going to be enabled when you have credits. I think I have. Oh no, this is another person's project, so I cannot edit. But if it is your own project like this, you're going to have the auto layout enabled. You click here, and then Copilot is going to be doing all the wiring in the PCB layout. So it's essentially connecting all the different components together. So definitely plus points for somebody that can show a fully routed design versus a non-fully routed design. So kind of like the stages would be full schematic, or partial schematic, then full schematic, then full schematic with component placement, essentially meaning that you move all the components to the right place. I mean, this USB will be on the edge. This component will be close to the other components that it's connected to. That's going to be the next stage. Following stage will be the routing. So connecting, make sure that you have all the routes that connect all the components together. That will be the next step. Again, you can use the auto router for that. And then the next stage would be this with an enclosure or a custom board layout. This is just a square, but you can use a layout shape and then do something better. I mean, for example, it's going to be like a flux shape. So if you do custom shapes that make sense for your specific workout, for example, an AI pendant could be a circle or some weird shape, of course, plus additional points for things like that.
Awesome. Thank you, Nico. That was all the questions we had in the chat. And for context for everyone, we're going to have the Flux team is available through the Slack channel. So don't feel like you need all of your questions answered now. This session's also recorded, so you can rewatch it throughout the day. And Flux has a ton of different videos, docs, getting started guys, resources too. So as we wrap up from this intro call, there's so much to get started on. We just wanted to make sure that we had a centralized intro so that we could get started. So Nico, thanks for kicking us off on that side. We're not, just because that part is over doesn't mean the support is over. We're still, Flux team is still here and ready to support, and there'll be more resources there. The last two things we're going to do in this kickoff, one, just get to meet the different people on this call. If we were in person, that's one of the best parts of the hack. So we're going to do 2 rounds of breakout rooms. These are totally random. The first round of breakout rooms is just going to be 10 minutes, getting to talk to, introduce yourself. Who are you? Why are you here? Any ideas you're looking to build? And the goal in 10 minutes is just to get to know each other, to see who else is in the room, see if you might want to work together. And then the second round of breakout rooms, we used a very complex algorithm called randomness. Those are going to be the first draft of teams. That first draft of teams, it's just a draft. If you want to work solo, let us know. If you met someone in your first breakout room you want to combine with, that's okay, let us know. The second round of breakout rooms is just to help accelerate the team making process, and you can adjust even after that. So first round of breakout rooms, we're going to open up. You've got 10 minutes. There's going to be about 3 people in per room. Just have a good conversation. Who are you? Why are you here? What ideas are you thinking to build? And then we'll come back and help make teams for the second round. If you have any questions, we're going to be in the main room, so you can always drop in here. All right, breakout rooms are open. 10 minutes, introductions, and then we'll be in the main room if you have any questions.
Hey, Ethan, do you want to talk now?
Yeah, sure.
Okay, you want to split out or do you want to talk here? Because basically we're just planning in public, so we can plan in public right now if people want to listen in.
Sounds good. I'll put you both in the same room so you can start jamming.
Awesome. Thanks.